Welcome to Section 11, Lesson 11. A nonlinear system has at least one equation that is not linear, often a quadratic or higher. The same substitution and elimination ideas from Section 5 extend to nonlinear systems, just with quadratic equations replacing the linear ones at the solving step. The most common pattern one equation is solved for y in terms of x. Substitute that expression into the other equation. The result is a single variable equation, usually a polynomial. Solve it, then back substitute to get the y values. The number of solutions equals the number of intersection points between the curves. A line and a parabola can meet at 0, 1, or 2 points. A circle and a line can meet at 0, 1, or 2 points. Two parabolas can meet at up to 4 points. Today's two examples cover a parabola line intersection, a circle line intersection, and two parabolas. The procedure is the same in every case: substitute, solve, back substitute, list pairs. System y equals x squared and y equals x plus 2. The first is a parabola, the second a line. Find their intersections. Both equations give y in terms of x. Set the y expressions equal x squared equals x plus 2. Move everything to one side. X squared minus x minus 2 equals 0. Factor x minus 2 times x plus 1 equals 0. Two solutions: x equals 2 and x equals minus 1. Back substitute. At x equals 2, y equals 2 plus 2 equals 4, so the point is 2, 4. At x equals minus 1, y equals minus 1 plus 2 equals 1, so the point is minus 1, 1. Two intersections, both visible on the graph. A circle x squared plus y squared equals 25 intersected with a line y equals x plus 1. Find all intersection points. Substitute y from the line into the circle. X squared plus quantity x plus 1 squared equals 25. Expand and simplify. X squared plus 2x plus 1 equals 25. 2x squared plus 2x minus 24 equals 0. Divide every term by 2. X squared plus x minus 12 equals 0. Factor x plus 4 times x minus 3 equals 0. So x equals minus 4 or x equals 3. Back substitute. Y equals minus 4 plus 1 equals minus 3, and y equals 3 plus 1 equals 4. The two intersections are the points 3, 4 and minus 4, minus 3. Two parabolas, y equals x squared minus 1 opening upward and y equals minus x squared plus 5 opening downward. Find their intersections. Set the two y expressions equal. X squared minus 1 equals minus x squared plus 5. Solve. Add x squared to both sides and add 1 to x squared equals 6. Divide by 2x squared equals 3. Take the square root. X equals plus or minus the square root of 3. Back substitute. At either value of x, y equals x squared minus 1 equals 3 minus 1 equals 2. Both intersections share the same y coordinate of 2. The pairs are root 3, 2 and minus root 3, 2. Symmetric across the y-axis, as expected for two parabolas with vertical axis of symmetry. 3 takeaways for nonlinear systems. Substitution is the standard technique. If one equation is already solved for y in terms of x, plug that expression into the other equation. If neither is, solve one for whichever variable is easiest first. Solve the resulting single variable polynomial equation. The degree determines the maximum number of intersection points. Linear into linear gives 1 point, quadratic into linear gives 2, quadratic into quadratic gives up to 4. Back substitute every x value into one of the original equations to get the corresponding y value. The intersection points are xe pairs. Always verify each pair by checking it satisfies both original equations.